So let's get started. So today we have afternoon we have tests. So just to remind you the location first before do anything. So the test will be held at today 4:35 to 5:35 in YIALT 5. And it's open book, but it's not open iPad or laptop, so you have to bring the cheat sheet. Then have to be physical one, right? Non-electronic version. The cheat sheet cannot be shared, and you can bring your calculator, but you can't use iPhone to do or smartphone to do calculation. So remember your calculator. And the Z table, F table will not be provided. You can bring your own version, okay, because you are allowed to bring anything, so you can just bring your own version. If you ask which version you want to bring, you can bring the one that I provided, should be sufficient. Okay, and also bring your student ID. We need to see your ID and your signature to make sure that you're the one who took the test. And if you have legitimate reason to be absent from that, we need prior approval. I mean, you have to send me an email. Okay, and then you got approval, only then you can do the makeup. Okay, and without approval before the test, then you don't. Okay, you consider absence. So now I guess that should be pretty much there. So we are going to look at the past paper, last year paper here. Okay. So I guess recover 1A and 1B there, right, last time. So I guess it's good time to go to 1C. Okay. And I hope the question to you, but if not, then you can just do the downloading. Okay. Okay. Now, so the question says you have a group X with 10 boys and 40 girls, and another group with 5 boys and 45 girls. And we're going to pick one student from them, but first we are going to do it in 2 steps. First, we're going to pick a group, okay, and then once we pick the group, and then we choose one member from the group, okay, and we found out that it's girl, then the question is how likely that he is from X, right? So to do this question, I mean, you can draw a tree, right? That's what we do, right? That's what we do in the slides, right? So this is 2-step process, right? So we start from thinking we are choosing 2 groups, right? X and Y here, right? Each of them is equally likely that will happen, right? It's the first step. I mean, remember the question, right? Look at the question again. The question said you choose the group in a random, okay? Only 2 groups. Random means half likely is X and half likely is Y, right? And once you choose the group, right, you end up either boys or girls. You pick up one person. Either you have girl or boy. Okay. And either you have girl or boy. Question here. So here's a question there. I'm not intend to answer any question before the break. So let me answer them when I do the break, okay? So there are girl and boy and girl and boy. For X, okay, how many girls and boys are there? You have 10 boys and 40 girls, right? So how likely that you get a girl? 10 out of, let me check again. How many girls in X? 40 girls. Okay. This is 10 out of 50, right? And this is 45 out of 50, and this is 5 out of 50, right? So that is the part that we have, right? This is the probability tree that we have, right? So the question is a base rule, right? So that's why we have the diagram, right? So the question is asking, suppose with a girl, how likely this is come from X, all right? So that, sorry, given this girl, how likely come from X? Okay, so that's a question. Is there any question about what the question is asking? Okay, I mean, I represent the question in this form, so I think pretty much it's pretty straightforward, because how do we do this is going back to the slides, look at the probability. Okay, just to remind you how we do that is we'll use the Bayes theorem. So just pick up the Bayes theorem from your slide. Okay, the Bayes theorem is like this. Okay, B given A, just reverse it, right? Times what in the front and divide what at the back. Okay, so let us directly apply that here. Okay, so that would be a fraction. Okay, and denominator is just probability of G, right? And numerator is just you flip it around, right? And this. So this is the crucial step, right? Once you have this, and everything can be read directly from the table, more or less. Okay. First, let's look at the following. Look at the numerator, the most simple one, probability X, right? You draw how likely that you end up with X, right? Look at this, it's 1/2, right? Because you're choosing X and Y at random, right? So it's 1/2 there. So that is what you have. Second one is this guy, right? Given we have chosen X, how likely is a girl, which is given from this one, right? This is. Is that okay up to here? Is that okay? So the slightly difficult problem is the denominator, which is asking how likely you get a girl, right? So if you still recall our assignment, how we do that is what we use the total probability rule, right? So how we do is the probability G given X times probability X plus probability G given Y times probability Y, right? So that would be the expression, right? Because it's you have girl, either you have girl from group X and girl from group Y, right? The first one give you the girl from group X, right? And the number here is just 1/2, right? And the number of this is just 40/50. You may ask why, but look at the numerator, same as the numerator, right? And the next will be this one is 1/2. Y is here, right? And the very last step, that's this guy, which is 45/50, right? So done, right? Just plug in all the numbers, then we are already over, right? Is that clear how you would do this question? And if you try to think more carefully, right, how we do that is simply because we know G has happened, right? So basically, it's like this, right? The new simplified graph is like this, right? G is here. Only G had happened, right? So we know this is going to be true. And, right? So basically, we're asking how likely this happened over the other, right? So that means that I have this over the sum of the two, right? So that would be the other way to think the problem, right? Because there are only two choices, and because the total of the trees must be 1, so we just we normalize everything into 0 to 1, right? So that would be the another way to think. Any question before we proceed? No. If no, then we are going to look at the next question, which is question 2 here. Okay. The question 2 here said I have random sample of 50 customers, out of which 20 are male and 30 are female, up to 50. Okay. And male customers spend 100 on average, and female spend 120. And the sample standard deviation is 10 and 15. Okay. And assume everything follow normal. Okay. And let's write that down in our whiteboard first, right? So what it says is we, in our model, we're a bunch of boys. Okay. And a number of girls. Okay. And in the sample we got is so there's a question. What do you mean by combination form? You mean you do combinatorics? You get the final answer correct, then we'll check your middle step if it's right. Not sure what you mean by combination form, but that's what I'm saying. So we do a random sample of how many women you got? 30. Okay. And how many men we got? 30. Okay. And what is the average here? Is 100. Right. And the S is 10 here. Okay. And X bar is 120. And S is 15. Let me check if I do the question correctly. Yeah, let's see. So that is the question, right? So that's right. We write down this is the question, okay? So we can proceed, right? So this is the question, and we assume this is normal, right? So basically, at the background, normal here, right? And the background, there's a normal there, but that is in our mind, okay? So look at 1A here. Compute 90% confidence interval for mean dollar spent per visit for male customer, right? So very straightforward, ask you a 90% confidence interval, okay? And so we have to focus ourselves on the male, okay? Here, focus on the male. And let me revisit, we write that in here. So we do 2A here. Okay. What we have is X bar is 100. This is right. Yes. And N is 20 and S is 10. So that's what we have, right? So the next is review what we know, right? We want a confidence interval on this guy, okay? And it's important to recall what do we know about X bar, okay? Remember, X itself is following the normal. So X bar is also a normal, right? So a bell curve, right? And the bell curve will be somewhere the mean, which we don't know. We want to know, but we don't know where the mean is. But we know this is going to, if I have the sigma, right? Then I know how the shape of the sample mean looks like, right? It depend on the number of data you get, right? The N, the bigger, the more squeezing, right? That's something we know, right? And suppose the case we know sigma square, right? So what is confidence interval? If you still recall, right, is whatever data we have here, right? We go left and right by margin of error called ME, right? And what's the ME here? If we know, right, will be Z alpha over 2 sigma over root n, right? That is how we would do, right? If we know the sigma, right? No sigma, this is a normal. We can use Z, right? In that case, the confidence interval, right, will be X bar plus minus ME, right? That would be, or if you want to be more explicit, would be like this, right? If we know exactly this guy, no sigma, right? So that would be how we do it, right? If you know the sigma. But in this question, sigma is not given. You don't know the population, standard deviation, or variance. So what can we do? If you look at the slides, we emphasize, if you don't know, then we will use the T, right? So this question would be very similar. If you don't know, then we use this formula, right? Instead, you replace this by T and minus 1 alpha over 2 S over root n, right? So that is being proved by a guy called student, right? That's called the student T distribution, right? And you have to be careful. You look at T n minus 1. Okay, so that is the we do. So you can simply plug in, right? So the answer we need to write is like this, right? The 90 percent CI will be X bar plus minus T, right? N is 19, right? And for 19, then it's 0.05, okay? Y in the middle is 0.9, so left is 0.1, so it's 0.05 here, 0.05 here. And T is asking the tail, right? It's 0.05 here, right? Okay. And this S over root N, okay? So that is how we do this, okay? So X bar is there, S is there, root, and N is there, you take the root, right? So the only thing that possibly blocking our way from the solution is the T 19.05, okay? So first, I tell you how we do this in Excel, which very quickly, right? This guy is simply T inward, right? 0.95, 19, right? So that is, maybe the 5 I write better, right? This is like very, okay? So that is what we will do, right? But of course, some of you ask, hey, I don't have the Excel, right? I have the T table in the test in the afternoon. So how can we figure this out? Okay. Let's look at the T table that you might have or you may bring. You bring anything you want, but if you're super nervous this year, I create this table for you because I thought you were able to do it by yourself. But anyway, since you asked, I just do it, okay? So just be careful, look at what T table you got, okay? The T table we got is this guy, okay? Is the 1 minus alpha, the center, okay? And you may ask why I create this, but this is the most common T table you might got in the internet. So that's why I use this one, okay? And remember, I want 90% confidence. Actually, the alpha is just 10%, 0.01, okay? So go to here, okay? My alpha is 0.01. So basically, I'm looking at this column, okay? This column, okay? And the next is, we want 19, right? So we just pick up this one, those other color, right? So we, okay? So the intercept will be this guy, right? Right? So that is what we want, okay? That's a number that you will plug in your answer there. Is that clear? Okay. Do remind yourself this is T, so that you have to be careful. Okay. Is there any question before we proceed to part B? Raise your hand if any. Okay. So let's go back to the question. Okay. So that is what we have, right? So just plug in all the number, then we're done, right? Nothing deep there. Okay. Of course, in the exam, you don't need to show me so complicated step, right? You simply just do this and you're done, right? So just to remind you, this time I make the question paper easier in the sense that you will write your answer in the question paper as well. I leave some space in the question paper to write down there, so you don't have to worry about too much document here and there. Okay. Is there any further question for this one? If no, then we go to the next question. Next part is we want to calculate 95% confidence for female, right? So that is not something super complicated, okay? Right? So what we have is we want the female to be, right? What with X bar is 120, N is 30, right? And S would be 15. Okay? So what we need to do is 95%, right? 95% CI, right? And I'm not going to repeat the theorem, but this is what we have, right? X bar plus minus Tn minus 1 alpha over 2, and this is S over N, right? So basically it's 120 plus minus, right? This is T 29, and this is 0.025 and 15 over would 30. Okay. And just to remind you why this is the case, right? This is 95%, right? And this part is 0.025, and this part is also 0.025. So that's why we have 0.025 here. And the last step is look at this value, right? That's blocking our way from the solution. So just recall how to do Excel first. T inverse 0.975, 29. Okay. And let's, right? So that would be the thing. If you, in the exam, if you really panic, you can write this Excel function. We'll give you some marks for that. Okay, if you are really panic, but I expect you to know the final answer, right? So how do you find that? Remember, middle is 0.95, right? So alpha is 5%. So which look at the table here. Look at T again, right? We're looking at this column. Okay, this column. Okay. And 29 is the row here. Okay. And then that means that what we have is this guy. Oh, sorry. Should be the highlighted here. 29 here. Right? So the answer you would be seeing, oh, this guy. Okay. Anyway. Right? Look at this column and this number, 2.04. Right? So you put in the number there to be able to see it. Okay? Right? Is that fine? You see what I'm doing there, okay? And shouldn't be an issue. Now we have done A and B, so let's go to C, D, E, okay? And look at the question. You notice C is asking that if assuming the boys and girls have same population variance, so they are the same shape, okay? We're asking if there any evidence that male customer is less than the female at 5% significance level. So it's a question about hypothesis testing, right? So C is hypothesis, right? So it's important always as a method to solve this problem, hypothesis testing, you write down what the hypothesis is, right? It's the the standard procedure, right? We are saying that the male and the female have the same mean under the null. Okay. Remember, in our class, what we learn is always the null is always equality, right? That's what we have been doing. You may ask why we have to do that, because we just know how to do it for our undergraduate study. We don't know how to do it other way around. So, and I think we have this, right? 1 being the male and 2 being the female, right? So there's a question we have, right? We're asking whether female is more than male, right? This is the question. You guys look puzzled, so let's go to the question again to see, right? Asking whether male is less than female, okay? So that's the question, okay? So if you recall what's the question, right? This is a 2-sample t-test with equal variance, okay? The formula you have is like this, right? The test statistics you can calculate, because equal variance, that's what you have. Right? That actually follow a t n1 plus n2 minus 2, right? And what's SP here? SP simply n1 minus 1, n1 plus n2 minus 2, s1 square, n2 minus 1, n1 plus n2 minus 2, s2 square. Okay? So you can simply calculate that, right? Plug in all the number there. Plug in all the number there. You can have the t. Okay? And since this is a 5%, right? You can calculate the critical value, right? Which is t is 48, right? Because it is here is 95, right? Sorry, this is a one-tail test, so left tail is 5%, right? So the critical value here is negative, right? 0.05, right? That's the critical value. Or Excel, this critical value will be t inverse 0.05, 48, right? It's the critical value. Once you calculate this guy, right? You compare your calculation with this number, right? If what the test statistic is less than the critical value, then you reject, right? And that would be the thing you will be doing, right? Or you can calculate the p-value, right? The p-value will be given by Excel will be t this. You calculate this t, right? Put it here, put 48. True, right? This will be the p-value, right? That is how you would get your answer. Okay. That's if you know the formula. And as I said, for 2-sample tests in this semester, I'm not expecting you to know this formula. So what you'll be doing will be using the Excel function called t-test, right? So what I'm expecting you is to look at your Excel spreadsheet. Sorry, not spreadsheet. Look at your slides, right? You have a 2 sample equivariance, which is here, right? Is t-test x1, x2, 1, 2, right? And do note that this is the right tail. You need to subtract from 1 to get the left tail, okay? So how are you going to show me your input, right? So you just write down that let x1 be observations for male, right? And x2 for female, right? The input will then be just the p-value, right? Is t dot test, right? x1, x2, and sorry, 1 minus, right? Let me just write the p, maybe simpler, right? Maybe it looks more simple, right? P-value just 1 minus, right? Let me look at the formula here. It's 1 and 2. 1 and 2. Okay? And you will, if P is less than 0.05, then reject X null at 5% significance. Okay, so that is what I expect to see, right? Of course, I also expect you to give me this one, right? So give me this guy and give me this guy, then we're done, right? I just need to know your Excel input, right? You tell me the hypothesis testing, you tell me what the input is, tell me how you make the decision, then I'm done, okay? For the 2 sample, I'm not requiring you to write down the formula, right? So I think it's, right? So that's what I meant when I need you to write the Excel, right? Is that clear? Is that okay? Any further question? Because it's right tail. Right tail, the t-test give you the right-hand side probability. Is that clear? So look at the answer, look at the what they give you. Okay, this is the right tail. Okay, but the okay, it really depends on how you write the thing. Okay, so if you write 1 is female, 2, 1 is female, 1 is male, then you can just do the t-test. Okay, depends on how you write that. Okay, so have to be, that's why you need to write who is male, who is female, right? If I swap x1, x2, then you're fine. Okay, is that clear? Any question? Yes. Sorry. Oh, the question is gives you directly. Oh, because he said, is there any evidence the male is less than? Because it's something you want to see. So that's the question. Is it less than? Is it more than? Or is it equal to or not equal to give you directly? So basically, we want to see evidence to say this, right? So that's why this is usually, this is what is the x1, right? This x1, right? Of course. Is that okay? The reason is you don't care it's more than, right? So you only care about less than. Okay. So the next one, D, okay, that is actually we doing what we do for the C, but now the two things is different. One, we're saying the variance are not equal. So you use another formula to do that. And there's saying evidence they are equal, right? So let us write down hypothesis first, right? So 2D. Okay. What you do is this mu1 equal to mu2, mu1 not equal to, okay? Not equal is coming from the question, right? Asking they're equal or not, right? So you see, 1 is the male, 2 is female. Okay, so this is what we are using, the notation. And if you recall how we do this, the T will be x1 bar minus x2 bar over S1 square over N1, S2 square over N2. It will follow the V, and V is a monster that I'm not going to write that down, but you can easily calculate that, right? Which I asked you to do for the previous cohort. So luckily you don't have to do that. Okay. So what you do, right, is you will do the t-test, right? The p-value t-test. If you don't recall the Excel function, which usually I don't recall, so just check it out, right? Look at this equal variance. I don't have equal variance. So this is, it's 2 tail, it's 2 and 3, right? So what we'll do is we have to tell them what's the x and y first, right? So let's do the following. Okay. So this one you can just, we put it aside, right? So we need to say let x1 be observations for male, right? And x2 for female. Okay. My p-value is equal to t dot test, right? x1, x2, and 2 and 3. Let me check if this is correct. Yeah, 2 and 3, 2 tail t-test, unequal variance, and that's the formula. Okay. And we do 5%. So if P is less than 0.05, then reject H null at 5% significance level. So that's how we do, right? Of course, you do this assignment already, so I don't need you to repeat yourself again. Okay? Is there any question? Is that okay? Is that okay? Okay, so so now I think we should break because already 10:16. Okay, let's break first. I open the U reply. I will answer the question first before I continue. So let us have a U reply. Have a short break of 15 minutes. If you have question, please leave there so that we can revisit them. So you leave a question here, then I will answer them, including the people in the Zoom. You can also leave it there. Okay. If you have leave it in the chat, I'll answer that question as well. But if you okay, so that would be the so feel free to leave the question there. We will resume at 10:32. Get something. So let's see. Hopefully you leave your comment, suggestion, or question there so that we know, try to respond them before I answer them. First question is, which 3 chapters should we focus on? Did I say I only asked 3 chapters? No, right? Because look at, I have 3 questions, but it's not 3 chapters, right? Say this question A already include many chapters, right? You have probability, you have random variable, you have summary statistics, right? So 3 chapters here, right? And also we have estimation, hypothesizing, ANOVA, right? So not clear what do you mean by focus on, but since you learn statistics, right? And you learn estimation, one thing you learn is what is unbiased estimate of the future exam is the past exam, right? The last year paper is unbiased, efficient, consistent estimate of what you expect to be, right? So so you are, well, people say it's very stressful, but you are reminded that exam only 40% of your grade. So you also have project and right. So I would say for many of the cases, I mean, the distinction between A and A minus for the top students, right? And the project can be crucial difference. Okay, but to give you a little bit relax is the median grade from the past 4 years I taught 3 years I taught this class, the median is B+, right? So you should expect something you would do B+, right? If you do normally in the class. So if you get B from me, then unfortunately you're not very good, but well, maybe you're not having good luck for exam. But in general, then I don't see too much problem. So stressful. Well, because I think if I give you longer, it's more stressful, right? Because longer exam means harder, right? I can make it so easy because I make it short. Okay. I don't know whether you want a longer hard exam or easier short exam. I think you suffer less, right, for 1 hour, right? I don't know if you want to suffer 2 hours or 3 hours. That would be much more difficult thing, right? I think this, after 3 years refining, I think this is a appropriate level. I can tell whether you know or not. So just to remind you, if you have any suicide thinking, please contact relevant person. It's not the end of the world, right? Even if you fail the exam, but it's not easy to fail my class, even you fail the exam. It's very difficult. Unless you are not doing all your homework, not attending the class, not doing assignment, it's not doing the project, right? Otherwise, it's very, very difficult to fail. Okay. You can try, but I mean, it's very difficult to fail this class, I would say. How to read T-table? Okay, let's do it once quickly. T-table is here, right? So just to remind you, there are many words on T-table. Okay. In this T-table, what we got actually is a critical value, right? From this table, right? You just give me alpha, I give you the alpha below, right? So it's more like T inverse, right? It's the T inverse, right? So alpha is the middle, right? So if I, for example, go back to this one, right? How can we read this table? I want 95% confidence, right? That means that the alpha is 5%, right? So that means that when I read my table, right? I just look at 95 is here. So the alpha is 5%. So I just read this column, 5%, right? And depend on what we're doing, usually n-1, you read the number of rows. I hope that is clear. Suppose your n is 10, right? It's there. Okay, do note that you read the n-1, right? Or n-2, the n-1 depends on situation. But I guess this is relatively clear. Next question. T-table, you cannot read p-value. I emphasize again. Okay. For T-table, I gave you, you can't read the p-value. If I got crazy, suddenly ask you, if you happen to see that, you just give me the Excel formula. We're fine. Okay. But I'm pretty sure I didn't make the mistake, but that's the case. And yes, no two-way ANOVA, up to one-way ANOVA. That's it. Is that this is 1.95, how to convert to p-value? Not sure what you mean, because this is the critical value. It's not the p-value, right? I mean, just to make sure that it's clear what we have, right? 1.65 is what? It's mean the following, right? It's 90%, right? This is 5% here, 5% here, right? That's that. This is 1.96. 1.64, sorry, maybe. Yeah. Oh, sorry. It's 95 here. 95 here, and 2.5 here, 2.5 here. It's 1.96. This is the critical value, right? So probably the question is, what is the p-value here, right? P-value, do note that p-value depends on your hypothesis, right? So suppose the H1 is, say, mu is less than A, for example, right? Your p-value will be, no matter where you are, you look at the area on the left, right? Doesn't really matter where you are, look always on the left, right? Then the p-value will be on the left-hand side, right? If your hypothesis is more than, then where, no matter where you are, the area on the right-hand side, okay? And if you are looking at two-tail, okay, which is, what color I should use here? Purple. If not equal, right? The p-value will be, regardless what you are, right? You look at left and right, which one is smaller, look at the smaller one, and you multiply by 2, right? So that will be the way we do the p-value. I hope that is clear, but we have been doing this all the time, so there's nothing very special. How do I find T88 from the table? Like this. So the question is T88.025, right? So the right-hand side 0.025, so this means 5%, right? So 5%. So how to pick up this is 5% here, 5% here, this column. Go to 88. I don't have, so look up 80. And then you're done. 5%. Look up the 80 one because you don't have 88, right? So look the smaller one. Okay. Okay. Thank you for taking the lecture. I know some of you are, many of you, or most of you are forced to take this class. So thank you for listening. How can we distinguish left tail and right tail? It's the question. The question tells you right tail, left tail, right? C less than. Oh, what's left tail? Of course, you define what is 1 or 2, right? So right tail, left tail. So look at the question C again. So I write male is 1, female is 2, right? So I care about the subtraction, then it's the left tail. If I write the female is 1 and male is 2, then you use the right tail. So it really depends on how you write it, right? So I hope that is the way that you write it. H0 is the null hypothesis. In our class, it's also equal, right? We are simple hypothesis. H1 is alternative. And the goal of hypothesis testing is to see if our data tell us whether we favor H1 over H0, right? Because the thing is, if H1 is true, then we do something else. So that is something we want to test. How will our ANOVA be tested? I focus on Excel output. So you will see when I talk about question 3. It's two-way, yeah, two-way is not in the syllabus. Yes. Okay. Number 2. Okay. Just to make sure, today is Friday, and we have test today. Okay. Don't miss it since everyone is here. Just let me do it again to tell you the location. Don't miss it. It's YILT5. Okay. 4:45 to 5:45. Okay. Let's make sure it's 1 hour only. So, some of you think it's cloudy. Yeah, probably. But after exam, you'll be sunny. All forgot. Actually, that is the highest level that you have, right? If you remember, some of you know the Chinese story, 呢個倚天屠龍劍 then that is what 呢個張無忌問呢個張三豐教佢呢個太極拳就唔記得晒。What he forget everything that he know, then actually it's the highest level you got. So if you forget everything from the class, then that's good because the principle already in your heart, in your mind, then you don't need to remember. You don't need to remember 1 + 1 = 2, right? If you forgot everything, actually the highest level, right? What is CIE? I don't know. Tree diagram. Yeah, past paper. Yes. Yes. That's good. So today, yeah, the speed is okay. And most of you able to follow, kind of. Oh, good. So this is a joke. So that means that it's easy. That's good. Hope the final is easy. So I would emphasize again, my exam is easier than assignment, which means that if you know the assignment, you should be able to do it. Okay, look at my assignment is more difficult than the exam, right? So it's not that difficult. T-test is already, you have the 2 tail already. Just remember the T2 test is you have 2 tail. So if you do the 2 here, it's already 2 tail. Okay? You don't need to multiply by 2. Already 2 tail already. Okay? Don't multiply by 2, otherwise you got a mistake, okay? 2 tail T-test is already, the T-test, if 2 tailed it, it's already 2. Okay? For F table, I think probably you don't have to worry about 2 table because I said for the 2 sample tests, you just focus on Excel, right? So F table is, you can print that. I mean, print that is fine. Yeah, to this last lesson. So everybody's happy. It's Friday. 1 hour is done. You are free. Want to be a dog in next life? Probably not in Korea, right? Or because Korea eat dog. Yeah, thank you and goodbye. No final exam. Oh, you say joke? Then yes, final exam. Yeah, you enjoy it, I think, once you see. Exams will be fine. Don't worry about it. You should be fine. Oh, yes. I recommend that if you can't sleep very well, you can watch the video. That's what my former student told that because, yeah, my tone is very monotone, so it's good to keep you sleep. Okay, make you sleep when you are tired. So I guess I answered all the question. Now what left is this, right? E at 5% level. Is there any evidence that the population variance by female is larger than that of the male? Okay. So it's compare variance. So immediately you know it's going to be F test, right? That's because it's the only thing we talk about comparing variance, right? So very straightforward. So just to remind yourself what is N1 and N2, we have here N1 is 100, N2 is 120, S1 is 10, and S2 is 15, right? So the question, I mean, 1 is male and 2 is female, right? So the question is, this is the x0 is sigma 1 square equal to this. Okay. Sorry, I forgot the question. The null is female is larger. Okay, female is larger. So I'll write that. Okay. Right. And the F test like this, right? S1 square over S2 square, right? So basically it's just 10 square over 15 square, right? And this is F. Oh, sorry. N is not 100, right? Sorry. N is 30 to 20? No, I forgot. Sorry. Let me get back. N is 20, 30. Then this, I check 19, 29, right? So what you would do is, this is number is what? Is 2 over 3 square, right? So it's 4 over 9. So it's 0.44444444, right? So the question would be, look at this, 0.44444 here. We want to check, because it's left tail, right? So we want to see if this is, the p-value will be this number, right? If used Excel, right? How to do that? It's very simple, right? We just F this 0.444, 19, 29, true. Okay, you compare this, then we're done, right? That's the p-value method. That's the first method you use. Okay. The second method, of course, you do the critical value, right? What are the critical value that this is 5%, right? So the critical value will be F inverse 0.05, because left tail, right? 19. Then that's it. You compare it, is it more than 0.444 or not? Then you're done, right? You do one of them, you don't need to do both. Okay. So if you have the F table, this is you can't do this, but you can do the F table. It's an inverse, right? And you have to figure out 19 and 29. Of course, depend on whether the F table you print out, do they have or not. In this question, as some of you said, I don't have that much. Again, also the one I gave is the right tail. So right tail, so you can't really use it, right? So you can't really use it, you just use Excel, okay? If you can't use it, okay? And some of you would ask, can I use the F test, right? And the question is, can I use the function f dot test here, which I talk about that. The problem of this is a two-tail one. Okay, then you can't go back from two-tail to one-tail, so you can't really do it. If this is a two-tail, then it's yes, but I asking one-tail, so you cannot go back, and that's why you can't use this one. Okay, is that okay? That's how you do the F. Is there any question? Any question? Okay. Here we come to the very, very last part, after which then you will be free. Because last question force regression, so I'm not going to talk about that. Okay. So this question is ANOVA, and you can see this question only have 4 numbers, right? So which means that you will have fun with the 4 number. That gives you 30 points, right? So just 1 number here, 2 number here, right? Only 4 number in this question. So I think it's the easier than any thing in your high school, right? Just 4 numbers. Okay. So let's read the question. The question said the company has 15 stores. want to know if the sales performance are different. And they have 12 months data for each store. Okay. And the Excel output like this. Okay, many people ask more Excel output I'm talking. This is the Excel output, right? So you need to understand how to read this, how to understand them. So that's the question. So if you recall how we do this, right, is the first column. Okay. Just to remind yourself what we do, right? We have this, if you remember, right? This is the formula. And SST is 180, right? SSW is 80. So what is SSG is 100, right? That's 1 plus 1 equal to 2, the same thing, right? Is what plus 80 is 180. So answer is 100, that's it. Yes. That's it. So, well, to write this, right? 180 equal to, where am I? So SS within, right? Right. SSG is 100. Done. 5 points. Okay. Well, although it's easy, I would say from previous experience, a lot of people fail to do it. Yeah. Don't worry about it. A lot of people fail to do it. So B, what's the missing value in the second column, which is the DF here. Okay. And if you recall, the DF here is what? This is the denominator to calculate the variance, right? So if you remember, between group means across different group. Okay. How many group we have from this model? You only have 2 numbers here. Okay. And they look at different stores. So store number of group is actually C, right? How many groups you have? You have 15 groups, right? And this is number of group minus 1. So this is just what? 14, right? So that's the answer. That's it. This part is not difficult, right? Because number of group minus 1, right? That's it. Because ANOVA is comparing groups, right? How many groups you have in this question? 15 groups. Because compare the mean of the sales of different stores are the same or not. So that is exactly the question is. It's C minus 1 because this is C minus 1. If you're comparing, if different months are the same, then it will be 12 minus 1. But we're comparing different groups. Is that clear? The next one, I think is the most tricky question. If you don't know it, then you fail the rest. Because that's the part that tricks a lot of people. Okay? Is this. This part is what? This is, if you remember within group, this is N minus C, right? C we know is 15, that's no problem. But what's N? N is total number of observations, okay, which is 15 times 12. So that is the hard part, and many people fail this one. Okay, okay, that is the part that not that easy to do. Okay, so if you able to do that, then you're done. Okay, so that is the hard part. Okay, and this is 100, right? Question C is asking you the column of the green, which is something that you spend 1 second, you can do it, right? Because this divided by this is that, this divided is that, right? Then you're done. Right? That is how the Excel said, right? The MS is just the SS over the DF, right? Once you can do it in no time. Is that clear? Now, come to the part D is F. F is something, you know, is MSG over MSW, right? The reason is like comparing between group variation to within, right? If between is very large, then it's going to reject, right? This guy is this divided by this is this guy, right? So you divide this over this, give you the F, right? Is that okay? Right? There's nothing deep there. So we know how to fill in this, okay? The last question, part E, is asking basically to figure out the way to conclude from this table, right? Either you do the p-value or you do the critical value, right? And this Excel output, right? But you also, to do it, you also require some your Excel input or look at the F table, right? Because F table actually you can read that, but of course you can use Excel to do that, right? First, how we do that? This guy, the p-value is very simple, right? Whatever value is called x here, the p-value will be just f1 minus this x. You put 14. So let me calculate this. 12 and 15. 180. 180 minus 15. 165. So this 165 here. 165. Why 1 minus? Because F test is this one is a right tail, right? Because the argument is the between group is much larger than the within group in order to reject, right? If you remember what the F test doing here is, we're doing this, right? The mu1 equal to mu2, mu15, right? And not all equal, right? So it's a right tail test, right? It's a right tail test. Okay. And look at this number. If this number more than 5%, then you can do it, right? You can reject. Okay. And okay, 165, right? And just quickly illustrate how can you read from this F table, right? This is 14, although I don't have, but what I do is look at the 14 column and read the 165 row, okay? Then you look at the critical value, okay? To calculate the critical value. Oh, so sorry, it's kind of gone, right? But how do you do this, right? This is 14,165, right? And this critical value will be F inverse, right? Use 5%, so it's 9, 5, 14,165. True. Okay. And this is the one that you figure out from the table there as well. Okay. You can compare this result to that, right? If it's more than that, then you reject, right? So since probably you don't have that in your table, you just write down this and tell me how you make the decision, right? You say if your thing is more than that, you reject, or your p-value is less than 5%, then you reject, right? So, but I would say you are able to make the decision indeed, but I allow use Excel for this one, okay? Since I said I allow use Excel. So you just write down clearly what you reject or you not reject, right? Then you're done. Well, you just tell me how, under what condition you reject or not, right? Oh, sorry, F inverse, right? Sorry. So you just compare, right? You would just tell me, so let me write, because since you asked, let me try to write that down. So how we do it, right? You would say, you calculate this guy, I don't know, 14,165. Oh, sorry. So my critical, right there, right? How you write? You say critical value, right, is F inward on 95, 14, 165, right? Then if the F you calculate from the table, right? That table, F is bigger than the critical value, right? Then reject H null at 5%. Right, so that. Oh, you have to write that down how you make the decision, right? Since you are not telling me whether you reject or not, right? But actually, I can say from the table, you can actually tell. But I allow you to write this conditional statement, right? You're supposed to give me the answer, but I think I'm generous this time. So if you just write down this kind of thing, or you write down the p-value, right? You can do the p-value, right? The F is what, right? You can calculate F, this F, 14,165, true, right? P is equal to 1 minus, say, if P is less than 0.05, then reject. I'm not going to write that down, right? Also like this, also fine, okay? But I would say you should able to, you can actually tell. But, okay, but I would be slightly more generous if you write this kind of statement. I will allow it to be okay, okay? But actually, you can tell. Oh. So, I guess I don't have much thing to say. Any question? I guess there's nothing nothing more I would say. So although now is 7 minutes before we should end, but I guess I have overrun many times in the car. So it's okay that I end now, but I'll answer question if you have any. So good luck. I will see you in the afternoon. Please be on time already. Make it 15 minutes after the usual time. So please be on time. Hmm? F test for ANOVA is all right tail, because we are trying to show you that because F test for the is always, we want to say whether it's the within group is, the between group is more than within group, right? The idea behind like this, if you recall the idea, right? We want to say no, it's not this one. The ANOVA is here. Right.
嗰個 alternative hypothesis 永遠都係嗰個 not all equal。
Not all equal.
即係唔會話其他